Hi, this is Mrs. Williams, and this recording is on logarithms. And logarithms, what we're really asking is this question: what exponent produced this? So we would have 2 question mark equals 8, and we're trying to find out what that exponent on the 2 would be. So that one's a pretty easy one to just think about. 2 times 2 times 2 is 8, so that would be 2 to the third power. But we can use logarithms to help us answer that, and it looks like this. Um, you have a few components to the logarithm. First one is the base, and that's the subscript number right here, the small number down below. Um, and that's really the number that you're multiplying by itself, the number that's raised to the exponent, but we put it down here in logarithmic form. And then how many times you use it in a multiplication, in this example, 3 times, that's your logarithm. So the answer is the logarithm, and that's really just the exponent on your number that you're multiplying. And then the number we want to get is an 8. So you can see this chart shows how the exponent, or the exponent and the bases are related. The exponent is your actual answer or your logarithm in logarithmic form, and the base is always the number. I guess you can kind of think of it here as it really is in the base as well because 3 is higher. So one way to think of your base is it's always in the basement. It's always the lowest um, number. Here it's bigger than the 3, but the 3 is still, higher, like a higher level than it. And then here, 2 is down below the 8, so it's in the basement over here too. So that's one way to kind of remember where your base goes. And here's just another example with arrows showing where all of those numbers go to. And this is probably the hardest part, is just remembering where all the numbers go when you're converting back and forth between exponent form and logarithmic form. But I'll give you some hints. We'll go through it here, and then also we'll do some examples, and I'll try to repeat this, so hopefully it'll stick in your head. But I've already mentioned one way to think of the 2 in this case, or just whatever your base is to think of it in the basement. So here it's really obvious. It's way down low, below everything else. Everything else is on, the this level, and then the A is down below, so it's in the basement. Your Y is your answer in the exponent form. And so if this is your basement, then this is your answer, and the basement begins with a B, answer begins with an A and B are next to each other in the alphabet. And then it equals your exponent, equal sign, exponent both start with an E, so you know those two things should be next to each other. So the X and your exponent would be on this side of the equal sign when you write it in logarithmic form. So that, if whatever you need to do to remember it, that's all that counts, but that's one way that might help. Okay, so on these examples, we want to convert the expression to logarithmic form. Okay, so we have 6 cubed, and we want to convert this to logarithmic form. So first we're going to find out what 6 cubed is equal to, and 6 cubed is, again, 6 times 6 times 6. It equals 216. Okay, so now let's try to write this in logarithmic form. So write log, and then you need your base right here. Remember, whatever's in the basement. And your base is the same. We call this a base in exponent form, and we also call that 6 a base in logarithmic form. So like I said, this is just your base, your exponent, because your exponent's higher. So just remember your number that's lower is in the basement, so we call it a base. And, well, I should say I don't really know that's where the base comes from, but it's an easy way to remember it. And then the number that goes here, this is where it starts to get confusing. It's not the 3, it's actually the 216. And so whatever your answer is, when it's in exponent form, this version here is in exponent form, your answer is inside the logarithm, like that. And so just remember, this is your base, which starts with a B. This is your answer, which starts with an A. And the A and the B are backwards, but at least you know they have to be next to each other. The base and the answer are next to each other. And then it equals your exponent. So remember, 3 starts with E. That's your exponent. And equal sign also starts with E, so that might help you remember that these two things need to be next to each other. Okay, so that's all you have to do, and then this is your answer if your task is just to convert it to logarithmic form. All right, so 8 to the 1/3 power. Let's figure out what the answer is first of all. So this is a good review on radicals. Hopefully remember that a fractional exponent means that you have 8 to the first underneath the cubed root. So remember, you are going to want to break the 8 down into its prime factors, 2 times 2 times 2, and you're looking for 3 of a kind, and so the 2 is going to come out. So I'll write this again just so that we have the 8 to the 1/3 next to the 2. So that's 8 to the 1/3 is really the same as 2. So now all we need to do is change that to logarithmic form. So you write log, and then the base of the log and the base in exponent form are the same. So 8 is your number that's going to go down here. Now here is, and basically you're just switching these two things around. So if you can remember that that would also work. Whatever works for you is what you want to use. But your answer in exponent form is what goes inside. Answer next to the base. A and B are next to each other. Equal sign is next to exponent. They both start with E. And that's your answer. It depends on what your directions are, but if your directions just say convert to logarithmic form, that's all you have to do. All right, now we're going to do the opposite thing. We're going to convert this expression to exponential form. So you can use the same idea. I like to start with my base. And remember, when you're converting to exponential form, you don't have the log in there at all. So you just drop that word. So you're just going to have 4. It's the base of the log. It's also the base in exponential form. And then you want to remember where your exponent is. So remember, your exponent is next to your equal sign. So the 3 is your exponent, and that equals the answer. And remember, the base and the answer next to each other. A and B are next to each other. So that equals 64. And that makes sense, right? Because 4 cubed does equal 64. So if you have all numbers there, now we will get into some problems where you have variables. But if you have all numbers, you can check and make sure it makes sense. And that one does. Okay, on these examples, we want to write this as a single logarithm. So up here, we have a couple properties that apply to logarithms. The first one is the product property. If you have two numbers, or maybe it's a number and a variable that are multiplied together inside of a logarithm, you can break it into two separate logarithms with a plus sign in between. Okay, and then quotient property is just division. So if you have two items being divided, you can break it into two logarithms with a minus sign in between. And in these examples, we're actually going to go the other way. We have it in the form over here on the right hand side, and we're going to put them together in a single logarithm using multiplication or division. So you want to handle these from left to right. Just like, when you're doing Please Excuse My Dear Aunt Sally, you always did subtraction and addition at the same time from left to right. Same idea applies here. So we're going to first take care of log base 3 of 15 minus log base 3 of 3. Oh, and I forgot to say how you pronounce it, but that's what you do. You say log base 3 of whatever's here, 15. That's how the vocabulary that you use. So you see a minus sign there. That tells us we're going to use the quotient property. And all you have to do, if you look at where the m and the n are, when it's written as separate logarithms, if you're going to combine it into the single logarithm, just remember that whatever is inside the first log goes in the numerator. Okay, so let me grab my pen. So we would write this as log base 3, and then because the 15 is first, it goes up in the numerator, and then 3 is second, it goes in the denominator. And you can just put parentheses around that part, just like it shows here. Okay, and then I'll write plus log base 3 of 4, and we'll take care of that in a second. But what you can do is just make sure everything's simplified down inside of the parenthesis here. We can actually change 15 divided by 3 just into 5. So we could just treat this as log base 3 of 5 plus log base 3 of 4. Okay, so remember my goal is to get this as a single logarithm. I'm not there yet because I have two logarithms here. So now I want to use my product property because I see a plus sign right here, and multiply the terms that are in the m and the n position, which are the 5 and the 4. So I'm going to just multiply those together. So 5 times 4. And of course you can do that in your head, but I wanted to write that out just so you can see what I'm doing. So log base 3 of 20, and now that's in a single logarithm, so that is my answer. Okay, so we're going to do a similar thing on this example. Again, you just want to go, sometimes you won't have, 3 terms. In these examples I do, but you might just have 2 terms. So if you do, it's just like I did up here with log base 3 of 15 minus log base 3 of 3. Once you'd get it into log base 3 of 5, then you'd be done if that, if those were the only 2 terms you have. Okay, so here, again, we see subtraction, and that's what tells you that you're going to use the quotient property and divide 16 divided by 4. So this one goes in the numerator because it's first. So we'd say log base 7 of 16 divided by 4, which is 4. And then we're going to add log base 7 of 3. And then again, because of this addition, that tells us if I want to combine that into a single logarithm, I'm going to use multiplication. And also, just as a side note, you do want to make sure that you only do this if the bases of the logs are the same number. In these examples, we're okay, this is 7 and this is 7. Up here, they were all 3. But just double check that. You don't want to combine them if they're different bases. So 4 times 3 gives me 12, and now I have a single logarithm, and that's my answer there. Okay, so on this slide we have a couple more properties. These are the power properties. And if you have a logarithm where you have a term inside that has an exponent, so in other words, there's an exponent inside of the logarithm, what happens is this exponent, this little p, comes out in front of the log. So right here they have p times log base b of m. And then if you have a radical inside, you can get rid of the radical by just writing the index in the denominator. So you just get rid of the radical sign and the index, just write that number down here. So let's try one. We're going to just try to write this in expanded form. So in other words, right now it's written as a single logarithm. We're going to try to break this apart using the properties that were on the previous slide and the properties on this slide. So one thing that I see in this problem is we have some multiplication going on. 7 times x cubed. So we can actually use a property on the slide before this one, the product property, to break it apart by using plus signs. So we could write this as log base 2 of 7 plus log base 2 of x cubed. So that's one thing we can do to expand it. And if I look at the first logarithm, I'm pretty much done there. I just have 7. And 7 is a prime number, so I can't even write those as, you know, 2 times 6 or something like that. If it was 12, you could even do that if you wanted to, but you just have a number here, and it's prime, so that's as far as you can go. Over here, though, we do have an exponent, so we can use this first property up here to expand it a little bit more, to simplify it a little bit more. So all we would need to do is take this 3 and write it out in front of the log. So your final answer here would be log base 2 of 7 plus 3 log base 2 of x. And that would be as expanded as you can get with what's there. On this problem, these two problems, we want to estimate each expression given that log base 3 of 2 equals 0.6309, log base 3 of 5 equals 1.4650, and log base 3 of 6 equals 1.6309. So really what you want to do on these type problems is you want to take what's inside of the log and write it in terms of the logs that are given to you. So we have a 2, a 5, and a 6. We want to write, we want to expand these logarithms to where they are written as log base 3 of 2, or they have a log base 3 of 5 in them, or a log base 3 of 6 in them. And what that will let us do, if we can write this as log base 3 of 2, at least part of it, we'll substitute in this decimal, and that will allow us to estimate it or to get a decimal for it and get rid of the logarithm. So for this first one, we have some division. This fraction really means you have 2 divided by 5. So we could expand that using subtraction as log base 3 of 2 minus log base 3 of 5. And you can see what that will allow me to do. I have log base 3 of 2 for this first part, and I know that that is equal to 0.6309, so I can replace log base 3 of 2 with 0.6309. And this one turned out to already be one of these amounts up here too. I have log base 3 of 5. And so again, I can just take the decimal that's equal to log base 3 of 5 and replace it in my problem. And then you can, those are just nice decimals that you have been using for a long time now. And you can just take your calculator or do it by hand and subtract those and get your answer. So you would get negative 0.8341. And the reason that it says estimate, it doesn't want you to like round this to the nearest tenth or anything. But if you actually had looked at the logarithms for these, or if you'd calculated them out by hand, these are rounded. The decimals here go on longer and longer and longer. So this actually, 4 decimal places, is rounded, and so that's what the estimate part is referring to. So don't estimate it or don't round it any more than they have. Just keep the 4 decimal places in your final answer. Okay, log base 3 of 30. This one's a little bit harder because we don't see the 2 and the 5 right away like we did on the first example. But just think about 30 and think about it in terms of 2 or 5 or 6. And there's at least a couple ways you could write this out. But probably the shortest version would just be to think of 30 as 5 times 6. So we could write 30 as 5 times 6. And then remember that multiplication, if we want to expand this log, is the same as writing the logs with the plus sign in between, like that. And then substitute. So we'd have 1.4650 plus 1.6309. Okay. And then add those together. Let's see, I'll do this. 3.0959. Okay, so that's the technique there, is just try to write it in terms of what you're given in the directions. Okay, now this last part is probably the one you're going to use, well, the product property, quotient property, power properties, those are used a lot as well. But this is also something that you're going to use quite a bit, so you want to know how to do this. Evaluate each logarithm to 4 decimal places. Okay, so the first one we'll do is log base 14. Now for this, you're going to want a calculator. You don't have to have a graphing calculator. Scientific calculator will do, but you should see a log button on your calculator. And that'll make these go a lot faster because calculating logarithms, my hand is not very fun. Um, it would take a really, really long time. So use your calculator. And so to do log of 14, all you have to do is just hit your log button on your calculator and type in 14 and hit enter. Some calculators you might have to type 14 and then hit log and then enter. So either log 14 enter or 14 log enter. You'll have to, experiment with your calculator and see, but the answer that you should get is 1.1461. Okay, and that is rounded to 4 decimal places. So that would be your final answer. Now, one thing I want to mention before we do any more is if you look at that log, you might be saying, well, there's no base there. It's just log 14. Well, if there's no base, it's always implied that that's really a 10. So just like when we were doing square roots, and let's say you had the square root of 4 and you knew that was 2, well, really the index right there is a 2. We just don't write it. Or just like if you have x, you know that that's the same thing as x to the first power, but we usually don't write the 1. So that's if you just have log and then a number, there's no base written. It's always a 10. And that's the only logarithm that your calculator will calculate for you. Well, I should say only one of 2. There are only 2 that your calculator will do, and log base 10 is one of them. Okay, so keep that in mind. We're going to use that knowledge in a second here. Okay, let's try natural log of 7. ln, the way you pronounce it, is natural log. And what it really is log base e. That's the same thing as the natural log. And e is really just a constant like pi. Most calculators, scientific calculators or graphing calculators, will have an e button. So you can press E on your calculator and press enter. You'll get 2.7182818828, or however far your calculator will go out. But it's just a number. So if you have log base E, just remember that's the natural log, and you also will have the natural log button on your calculator. So you'll see an ln. And again, it's always, you always know that the natural log has base e. So base 10 and base e, those are the 2 bases that your calculator will do for you. If you have anything else, you cannot use your calculator unless you convert it, and we'll talk about that in a second. So to take care of this problem, all you have to do is find that natural log button, the ln button on your calculator, and then type in 17 and hit enter, or again, maybe 17 natural log enter, one of the 2, and you should get 2.8332. Okay, now over here, hopefully you're looking ahead and you're saying, okay, I know I can't use my calculator for log base 7 of 17 because it has a base of 7, and I can only use my calculator if I have a base of 10 or a base of e. So that's where the change of base property up here comes in handy. If you need to change your base to something else, you can do that. You can change it to anything that you would like. So you can change this to either a base of 10 or a base of e. You don't really want to change it to anything else because, again, your calculator will not do it for you, and then you'll be stuck again. So you want to change this to either base 10 or e. It doesn't matter, whichever one you like. Usually, especially when you first start doing these, most students will like log base 10. So we'll use log base 10. And if you look at um, the property, what you're going to do is you're going to pick your n. Your n is the base that you're choosing. So in our case, we chose 10. And then the a is going to go inside of the log in the numerator, and your old base is going to go inside of the log in the denominator. So in this case, our 17 is going to go in the numerator, and then again you have the same log base 10 in the denominator, and then you write your 7 in the denominator. And it looks more complicated, it looks like we made it harder, but we actually made it easier because now you can use your calculator. So you can just type in log 17 and then hit your division sign and then type in log 7 because again both of those, if you just type in log, it's always implied there's a 10 there, and you should get 1.4560 if I round it. Oops, 4560. And that's your answer. So again here, let's practice this one. We'll change it to natural log. Okay, so again you can write it as log base e if you want to. And then the 30 is going to go in the numerator. Same base in the denominator, log base e, 9. But the better way to write it would just be natural log 30, natural log 9. Okay? So if you type in natural log 30 divided by natural log 9, you should get 1.5480. Okay? And just as a side note too, if you want to try it, you could have, or maybe you did, just to be devil's advocate, you changed it to log base 10 instead of natural log like I did. You should get the same thing. So if you, and again, it's really easy, fast on your calculator, just type in log 30 divided by log 9, you still get 1.5480. So I hope that helps, and let me know if you have questions.